Welcome back to Jackson Square. Today we're looking at TEK 6.10a and 7.10a, which say I can model and solve one variable, one-step equations and inequalities, or I can model and solve one variable, two-step equations and inequalities. So we are going to first jump in with what's an inequality? You know what an inequality is. You may not know what the word is, but you've seen inequalities all your life. So again, just like algebra, your teachers have been getting you prepared and ready with this algebra thinking the entire time. Inequalities are a math sentence that compare two quantities, okay? They're comparing two quantities. Why are they comparing? Because mathematics is not always equal. Everything in mathematics is not equal. Everything is not going to be an equation. That's why we have expressions and we have inequalities, because everything's not going to be equal. What's the goal of an inequality? Hey, to isolate the variable. That sounds so familiar, right? How do you solve inequalities? Just like equations. So if you can solve a one-step equation, you got this. If you can solve a two-step equation, you got this. Same process, same steps. The only difference is we won't have an equal sign, we'll have an inequality symbol. The inequality symbol is so important. That helps us with our graphing. So what are inequality symbols? I'm so glad you asked. Inequality symbols are the symbols you've seen so many times, and we've used them this year as well. Inequality symbols are less than, greater than, less than or equal to, or greater than or equal to, okay? And when we get to translating, the words are so important, okay? So less than, when we look for words like under, below, fewer than, okay? Greater than, more than, above, over, exceeds, increased. Less than or equal to, at most, maximum, up to is more than, okay? So, and greater than or equal to, at least, minimum, top is no less than, okay? Those are words you will see quite often, and you need to know what they mean. So let's highlight a few words, especially for less than or equal to and greater than or equal to. At most, maximum, up to. At least, minimum, no less than. These are ones that you're going to see quite often, and these are the ones that are new. We know less than, we know greater than. Less than or equal to. What does that mean? Less than or equal to means that it has to be less than this amount, but it can also be or equal to that amount, okay? So less than or equal to is commonly, you're going to hear the word maximum, maximum. So when I think of maximum, I think of the ceiling, okay? The ceiling. You cannot bust through the ceiling, but you can have that number and anything below. So that's why you see I wrote ceiling down. So that number down. So if the maximum of people that can attend my party is 150 people, I can't go above 150. That's my ceiling. But I could have 125. I could have 75. I could have 20. All of those people can be invited to my party, but I can't go over that 150 people, okay? Or what did I say, 175? Whatever my number is. That's my ceiling. So that's less than or equal to. I can have less than that amount of people or equal to that amount of people. That's maximum. Minimum. Minimum is the floor. That's the bottom. That's where you start and you go up. So to get into Club Zaza, you have to be a minimum of 18 years old, or at least 18. That means you can be 18, that's the floor. You have to be 18, but you'd be 19, 20, 30, 40, 75, 88 if you want to get in the club. That's your floor. That's the minimum. Minimum is the floor. So you start down and you go up. That's why you see the floor up. Minimum is the floor up. Maximum is the ceiling down. Okay? So just keep those in mind. When we're graphing on the number line, there's also going to be open circles and closed circles when we graph. So open circles are less than and greater than. Those are open. That means that that number is not included in the solution set, okay? That means it's not a part of the solution set. Whereas in less than or equal to and greater than or equal to, those numbers are a part of the solution set. Okay, they can be a part of the solution. So here's another important tidbit to remember. In an equation, you only have one solution. In an inequality, you have a set of solutions. So make sure you listen. I'm going to say it again. This is very important. In an equation, you have one solution. There's only one number that can make that true. If it's 8L equals 48, the only thing that's going to make that true is 6. 8 times 6 is 48. That's the only answer that's going to make that equation true. However, in an inequality, if I said 8L has to be greater than 48, there can be a set of answers that would make that true. Okay, not just 6. Anything that's greater than, 6 or greater, okay, will make it true. So you're going to see that because I'm about to jump in and we're going to do some models and explain this to you more detail. But remember, equation, one answer. Inequality, set of answers. You can have more than one answer or a bunch of answers. Okay? Inequalities can be represented on a number line. So here it says x is greater than 6. X is greater than 6. I'm just going to write that here. So remember, we want to know our symbols. And remember, if you don't know the difference between greater than and less than, if you take your left hand, and you make a little L, I can't even see my L. You make your L, and then you click it to the side. That's your less than symbol, okay? So you can always say, hey, this is not the same. Okay, that's not the same. This is less than, that's greater. That's how you can tell the difference. That's a little trick that you can use. Just take it. And if it matches, it's less than. If it doesn't, it's greater. Okay? X is greater than 6. So X is greater than 6. What does that mean? What are numbers greater than 6? 6.1, 6.2, 6.3, 7, 8, 10. X is greater than 6. So on this graph, I would put an open circle because 6 is not a part of my solution set, but everything past 6 would be a part of my solution set. So I would shade my graph to the right. Anything along this line will make this statement true. 7 is greater than 6. 8 is greater than 6. 6.5 is greater than 6. 6 and 1/10 is greater than 6. So all of these things will make it true. It's greater than 6. So we put an open circle. What does open circle mean? It means the point is not a part of the solution set. Okay? A solution set just means a bunch of answers, a set of answers. Remember I told you equation has how many? And an inequality has a set, more than one. Okay? So here x is greater than 6. Any number greater than 6 will make this true. Okay? 6 itself would not make it true. X is greater than or equal to 6. What does that mean? That means x has to be greater than 6. Or x can be equal to 6. So this one is totally different from the one we just graphed. It means two things. X can be equal to 6. So that means I'm going to have a closed circle this time because 6 is a part of my solution. Or x can be greater than 6. So this time I'm going to also shade everything that's greater than 6. But 6 is also included in this answer set. So we have a closed circle. Closed circle means the point is a part of the solution set. Okay, the point is a part of the solution set. So open circle, it is not a part. Closed circle, it is. Okay, and I'm going to write this out. X is greater than or equal to 6. Okay, just so you can have that visual and know. So let's go and look at some problems, and we're just practicing graphing today. Okay, we're not getting into deep, just which one's an open circle, which one's a closed circle, and how would that graph look. Solve each inequality and graph the solutions to each inequality below on a number line. So the first one says x is less than 2, right? That trick work. X is less than 2. So on my number line, I can first put some numbers. Whenever, if you have to create a number line, remember 0 does not have to be in the middle all the time. So you don't have to get stuck on that. For this one, I will put 0 kind of in the middle. However, like I said, it doesn't have to be. So you do not have to get stuck on that fact that it has to be in the middle. It can be way to the right, way to the left, or sometimes not even there. So it says x is less than 2. So the first thing you're going to do is you always put the circle on whatever number is in your problem. So my number is 2. Then I have to decide, is 2 a part of the solution set or not? 2 is not, because x has to be less than 2. Well, what are things that are less than 2? 1, 0, all negative numbers. So I would shade to the left, okay? You have to think, what are things less than 2? 0, -5. Those things are list, okay? Here we have x is less than, again, the trick works, less than -6. X is less than -6. Sorry, less than or equal to -6. Let me not forget that, less than or equal to. So anytime it says less than or equal to, I know that's going to be a closed circle, okay? Because if it's equal, that's going to be a part of the set. So anytime you have less than or equal to or greater than or equal to, closed circle, because that number is a part of the set, okay? Closed circle because it's a part of the set. So here it's -6, -8, -10, and let's see, I'll just do 4, -2. Okay, so this graph, I don't even have a 0 because it's not significant. I'm going to put a circle around -6 because that's the number we're talking about, and I know that it is part of the solution set. So I need numbers that are less than -6 or equal to -6. So -6 is already, the equal to part is already graphed. Numbers less than are to the left. Remember, as you go farther to the left, the numbers get smaller. Okay, so these things are less than or equal to -6. This one says x is greater than 5/10. X is greater than 5/10. So open circle, closed circle, shaded to the left, shaded to the right. Take a second, graph it. Circle on 5/10, and it was an open circle, and x has to be greater than. So numbers greater than 5/10 would again be to the right. 1, 2, 5, 10. Those numbers are greater than 5/10. So we're going to shade to the right. Okay? So I want to just throw in one more example of something. Now, first, here, if I had an equation, and I'm thinking of this equation from the other day, I'm supposed to be a W, I forgot. So m equals 48. Again, I would divide both sides by 6. M is equal to 8. An equation. If I was graphing an equation and my answer was 8, I would come in and put a dot on 8. Boom, I'm done. That's how you graph it. Equation, inequality. Totally different. Equation has one answer. Okay? Equation has one answer. An inequality has a set of answers. Okay? So we also want to talk about just quickly translation, and then one more thing and we'll be done. Write an inequality to represent the situation and graph the solutions on the number line. So again, this is where these key inequality vocabulary is going to come important. Be important. The temperature today will be no more than, okay? Temperature today, we don't know the temperature, that's T, my unknown. No more than 3 degrees. So no more than, I go to my chart. No less than, no more than. So more than is greater than, okay? But no more than is less than or equal to. So less than or equal to. The temperature will be less than 3 degrees or equal to 3 degrees. So you would translate this as T less than or equal to 3 degrees. Okay, so everything we did with equations, we're going to do the same thing with inequalities. So again, like I said, if you got them the first time, this is going to be easy peasy lemon squeezy. So we want to model this. Again, I'm going to put my circle on 3. And this is less than or equal to. Again, you can use your little cheat sheet I made for you. And that's going to be a closed circle. That means 3 is a part of the solution set. Less than, numbers less than 3, all are to the left. Okay? Numbers less than 3 are to the left. I'm going to show you a trick, a little trick. I don't do tricks often, but I'm going to show you a trick that helps you with your graphing. But it only works if the variable is on the left. So when we're solving equations, it doesn't matter if the variable is on the right or the left. You know x equals this, y equals that, b equals whatever. And then you can model or graph your answer on the number line because it's just that one. You put a dot, you're done. In an inequality, there's a tip or a trick that I can give you for graphing if it's a little hard for you, if you can't think of what's less than or what's greater than. But your variable always has to be on the left for it to work. So here, 7 is less than x. 7 is less than x. 7 is less than x. That's a little bit hard to think about. 7 is less than x. It's so much better when you say, hey, x is greater than 7. Oh, greater than 7. Numbers greater than 7, 8, 9, 10. But when you have to think of x is less than 7, that takes a little bit more brain power. So if I put x is greater than 7 and my x is on the left, if I draw a little tail on my inequality symbol, see that tail? It's pointing to the way I should shade. So x is greater than 7, numbers greater than 7 are to the right. It's pointing to the right. See that? So that's the way you should shade. Put your circle, which will be open on 7, and then shade to the right. Let's see another one. 0 is greater than or equal to x. Again, that's harder to think about. But x is less than or equal to 0. Oh, numbers are less than 0 or -1, -2, -3. So again, as long as the x is on the left, this trick will work. If x is on the right, this trick will not work. Don't try it at home, okay? So if x is less than or equal to, again, here's my inequality symbol. I draw a little tail on it, and then it's pointing, hey, shade to the left. Numbers less than 0 are to the left. Okay, so you're going to be encountered with some problems that will have your x not on the left. So you just rewrite it. So whatever direction. So here, the symbol is pointing towards the x. It's open towards the x. So when I rewrite it, I'm going to make sure it's still open towards the x. And that's how you know you're rewriting it correctly. So now I know that x is greater than or equal to 1. So when I graph, I'm going to be shading to the right because numbers greater than 1 are to the right of 1. Okay? So again, make sure that you are careful and you want that variable to be on the left if you want to use the trick on shading and graphing. So I hope this helps. Let's go practice.